Hi guys, it's Inventor Andy, and today we're going to be looking at the third and final tutorial for communicating with serial flash over SPI. In the previous two tutorials, what we did was we built a library for communicating with the serial flash device and for reading and writing to the device. So now we're going to implement that with a little bit of UART to show that the driver works and that you can read and write to memory. So if you go ahead and open the main.c file that was created as part of your project, and we'll get started. First, we're going to include a couple of STD libraries for Boolean and input-output. These just help with some of the functions that we're using in the test program. So std bool.h and stdio.h. Also, we need to include our ext flash library. So we'll include ext_flash.h. So now we're going to create some global variables that we're going to use in our test program. So the first is an IO descriptor for our UART. IO descriptor struct, and we'll call that debug.io. Next, we're going to create some flags for the receiving on the UART. So debug.io receiving and debug.io complete. Now we're going to define a maximum size for the message that we can take from UART and save to memory. So I'll call this max message size, and we're going to set that to 64 bytes. Now we're going to create a character array for our UART received bytes. And we'll set that to max message size. Next up, we need a byte counter. And we'll set that to 0. Okay, so now we're going to write our receive callback function. If you've looked at the asynchronous UART tutorial that I've done earlier, this function will look very familiar to you. Okay, so this function is going to be called every time bytes are received on the UART. So let's create our counters. Now we're going to read a character. So count is equal to IO read. We're going to read on the debug IO line into the character variable, and we're going to read 1 byte. Now we're going to check if we've received anything before. So if debug IO receiving, that should be false. So if we're not receiving, we're going to set the receiving flag. Reset the counter. fill the buffer with the first character. And then increment the counter. Otherwise, we'll just continue filling that buffer. So debug IO received bytes battery of counter equals ch, increment the counter. And now we're going to check for the end of the string. So we'll look for a new line character, and if we've got that, we'll set the completion flag. Okay, so that's our UART receive callback. Next up, we're going to create a function for initializing our UART. Static void init com port. So let's register the callback. So usart async register callback, and we're going to register this to debug out. It's a usart asynchronous receive callback. Debug rx callback. Make sure you delete those brackets at the end. Now we'll set the IO descriptor. So usart async get IO descriptor. We're going to get that from debug out, and we're going to store it in debug IO. Finally, we're going to enable asynchronous UART. So usart async enable, and we're going to do that on debug out. Okay, so those are the only functions you need outside of your main loop. So if we go to the main function now, let's call that init comport function. And then we're going to initialize our flash. So ext flash init. Now, in our main loop, we're going to check to see if we've received anything. So receiving is true. Now we're going to check if that's complete. And if it is, we're going to open the serial flash. So if ext flash open. Now first thing we're going to do is we're going to erase the first block. So we're going to erase at 0, the address 0, so the first block of data on the serial flash. And we're going to do this to flash erase sector size. So we're going to erase one full sector. And if that command was sent successfully, we are going to delay for a little bit, just to make sure that it's got time to actually perform that erase. Now, if you look at the data sheet for serial flash, that shouldn't take more than 240 milliseconds, so we'll delay by 240. Now we're going to create a buffer for our write data. So unit 8 data, and we're going to set this to max message size, and we're going to copy from our UART received bytes. So we're going to copy into the first byte. We're going to copy from our received bytes, and we're going to copy the maximum bytes that we had. Now we're going to try and write this data. So if ext flash write, we're going to write that to the first address, which is 0. We're going to write the maximum message size of bytes, and we're going to write the W data. Next up, we're going to create a read buffer. So int ATR data, max message size, and we're just going to set this to 0 bytes for now. Okay, we're going to attempt to read the data that we've just written. So if ext flash read, and we're going to read from the 0 address, which is where we wrote to. We're going to read our maximum message size, and we're going to store this from byte 0 of the R data array. Once we've read that data, we're going to create a response string to send over UART. So let's allocate that a size of, let's call this 128 bytes. And let's build the string. So we'll use the sprintf function, and we're going to store that to a response. And the message is stored in memory %s. So that %s is a string placeholder, and we're going to replace that with the R data. So what we're going to do is we're going to print out what we read back from the memory after we wrote into it. Finally, we're going to print that out to the console. So write that to debug.io. We're going to print the response, and the length of that is string length response. Now we're going to come out of this loop. So what we're looking for is pass the ext flash open, and then we're going to reset our flags. So debug.io receiving is false. Debug.io complete is false. So this means that it will start listening again for input data. Okay, so that's our little test program. If we go ahead to the data visualizer, and we're going to connect to our eDBG on the D21 Xplained Pro board. The board rate is 38400. If we click connect, and then make sure add/r/n is selected. So we're going to use this console to test our program. Okay, so we're going to go ahead and hit the debug button. And once that's flashed and running, if we go to our data visualizer, and we're going to write a quick test. So let's write the word hello. Now you can see stored in memory is the word hello. Okay, so that's the end of the tutorial. I hope that all makes sense for you guys. If you've got any questions or comments, please just leave them in the comment section below. I'll be happy to help. Thanks for watching, guys. I'll see you again soon. Hi guys, it's Inventor Andy here. thank you for watching my video. If you like the video, please click like, please subscribe to my channel, and please feel free to add any comments if you've got any suggestions for tutorials or videos that I can do. Thanks very much, guys.